I saw an opportunity today to get to talk about something that I wasn't quite frankly sure that we would talk about. And that was this idea of I don't know how I don't think you should write it all down. I think you should get to the main ideas. So like I would say, what is A? Not A, what's P? How much are we investing? So I would write down that P is 1490, right? Like that's going to be the meat and potatoes that we want. And then what is the annual interest rate? That's worth writing down. How often is the interest compounding? Right. And so I don't think I did a good job of this the first go round, but I think it's important that you guys are able to translate that when it says monthly, you need to take the formula up here, the one behind me or in your notes, and you literally need to change n into the number 12. Clear? I don't know that I ever explicitly made that clear, but that's like what monthly means is that n equals 12. And then, of course, we have t equals 51. So to summarize, we would say our p value, remember, was 1490. Our R value, what is R? Oh, 4.06. Careful. Most of us don't use percent buttons on our calculators. Very good. It's 0.0406. So I have never in my career taught the use of the percent button on a calculator. I feel like it's a safer bet for us just to always make things decimals. If you know how to make things into decimals, you can use like the little free calculator that comes with a box of cereal or, whatever. So easy peasy. So N is that, P is that, R is that, and of course, what is T? 51. Good. So there's what we need. That's the structure that we need to do this. And so to figure out how much money is going to be in the account after 51 years, we simply write A equals, and we're off and running. So what goes first? Right. So 1490 goes first. And then you'll remember this. We haven't done this in a few days, but in the parentheses, what do we put next? Always 1 plus. Very good. And then what goes on the top of this little baby fraction right here? 0.0406. Good job. And now what goes in the bottom? 12 does, because in this case, 12 is the n value. And then up in the exponent, I have to multiply n by t, and probably that's a tough one for us to do mentally. I got to do 12 times 51, and that's 510 plus 102. So I'm feeling like it's going to be 612. I want to check my math. Am I okay? 612. Good. Yeah. So let's practice because today I'm going to teach you a new formula, but I wanted to do a couple warm-ups for you here first. So, or not for you, but with you. So let's practice 1490, blah, blah, blah. And I'll put what I get up on the board, and then you and I can compare notes. So according to what I'm getting, there's going to be this much value in that account after 51 years. Why does that doesn't seem to me like a very good payout, right? 51 years feels like there should be more more payback, right? Why is that such a that's pretty wimpy, right? Like no one would say no to $11,000, but why did it only grow that much? It's a low rate, right? The interest rate, as we learned the other day, really is a kicker. Like a high interest rate is going to make all the difference in the world. So 4% is pretty puny, and that's why, that's a lot of time for money to sit in an account, and then you come out of it and you're only 10 grand richer than you were. Yeah, so that's a tough one. But all right, I prepared these before you got here because I was just feeling like I didn't want to type it all out. So again, let's just copy down the parts of this that are pertinent or important. So here we go. What is our p value? 1490. Good. What is our let's do R next. What's R? Is this the same problem? Yes. No.
Yes.
So sorry. What is happening out there right now? Is that Do I need to go over there? And we can leave the 0.25 out if you want. That's okay. Do you want to put it in? The best version of itself? Well, for what it's worth, in most problems, even over the course of like 60 or 70 years, it usually amounts to about like maybe a buck. So it's really not a big deal. Let's keep it simple. Let's keep it just 365.25. Let's completely neglect leap years because it's just not. So here we go. So for the daily, we know that n is 365. Remember, that's translates to the compounding occurs 365 times per year. And then what is t in this problem? Awesome. So let's do it. Again, it's just a matter of, do I know where to put all the parts and pieces? So I'm going to say a equals, and first off, I put my p-value, and then I put a big clumsy set of parentheses, and then I always put 1 plus. What goes on top of the fraction? R. Yeah, 0.0858. And then on the bottom of the fraction is 365. And this is definitely calculator village. And you would expect this, that if something happens 365 times per year and you do it for 65 years, that's a lot of times for something to. Yeah, it's a really big exponent there. So we have 23,725 is our power. Yeah, try that again. 365 times 65 years. You'll get this. Oh, where's the book put that? 23,725 is the actual exponent because we had to take our n and our t and multiply them together. N should be 365 since it's happening daily. And then t is 65 years. So you multiply those to generate the exponent. Yeah, no, this should be a significantly big answer. I think 65 years at a really good interest rate is going to be big. Are we all, I just want to know, is everyone on board with this? Let me type it in real quick, Micah, and then you and I can compare notes. So 9125 times 4 plus. Yeah, that's significant, eh? Yeah. What'd you get, Micah? You gonna try reading? It is. 409,000. Yeah, so we wind up with two. It's hard to say numbers when there's no commas. That's why I always get so cranky when you guys don't put them in. Anything longer than 4 digits, it's a courtesy to put commas, okay? So please always take that with you and do that. Someone has to read your numbers. Calculator doesn't do it because it's just a dumb calculator, but it's hard to decipher what it is. But anyways, it is 2 comma 409 comma 952.98. And I'm going to round that 7 up to an 8 because there's a 7 on the back of the 7. So that's a big deal. It just goes to show you the power of compounding interest, that you started with this problem with 9,000 bucks, and over the course of a vast portion of a lifetime, you wound up with that. So is that realistic? I mean, these things are all fuzzy. Like I had my financial guy from Charles Schwab come over. If that's something you guys are interested in, by the way, I could call him. He can come again. He can talk to you guys about mutual funds and investing. But he came over and tried to explain that, this is not, you can't go down and say, I demand that I get 8.58 interest. That's not the way investments work. Investments are going to bounce around, right? You know that. And so it's not really realistic to just say, wow, I can do this. Like you can try, but where you put your money and how you invest it sort of affects what kind of interest rates you get. So. Right. And so when you meet with a financial advisor, like if you guys want to say, I'll call Sam again, and he was happy to do it last year, but he'll talk to you about like, if you invest high risk, then you understand that with the high amount of reward you might get comes the risk of a high loss. And then there's a type of investing that's more long term, where you're not in it aggressively to try to make a lot of money you're not gambling very aggressively. So stockbrokers, people that do this for a living, know where to put your money so that there's not a lot of aggressive ups and downs. It's a very boring roller coaster ride. But what mathematicians and money people know is that while the ride may not be very exciting, if you're willing to let it sit there for 40 years, you're going to make money. Does that make sense? Yeah. So there's going to be like a high, medium, and a low. The medium is just for like more like, you know how it is. Like I can't decide on, do I want the extra hot green chili or the wimpy? I'll go with the medium. It's kind of like that. So yeah, what's up, bud?
My first word is in 0.96.
Did I type it in wrong?
No, we double check.
Um,
This one, and I double check the equation.
may I look at it real quick? I'm gonna pause this just super quick. But right now, there you go. So we good on this? Other than Aiden's calculator issues, we're good. And that's not an Aiden issue. There's something kind of setting on there that I need to work with. So this is where we start the other one. So there's a new word here, and I'm sorry it's taken me so long to get here, but you guys are good for the ride. So here we go. So this time, this goes into that idea of like what the British guy in the video is trying to show you, that like you see that you can compound every day. And if you agree that I could compound every day, then you agree that, well, I could compound a bunch of times per day. I could compound every second. But if you agree that that's possible, then you should agree that I can compound every hundredth of a second. And if that's possible, then you go, well, why don't I just make the interval shorter? I'll compound every millionth of a second. And eventually what starts to happen is you reach this concept of infinity. And you say to yourself, could I literally compound the infinity times per year? And the answer is, that's a tough one. It goes back to like what Aiden said about the circle. Like, does the circle have infinitely many sides, or does it just have one side? I don't know. And so rather than try to sit and work with the number infinity, using Euler's number E, we have a brand new formula for this particular type of problem. And I thought today's assignment I would give you will let you practice with this. And I even color coded it for you, and I made it stand out as green. So for this time, we are still going to make our checklist the way we always have. Let me ask you this as a question. If you're really listening, you can answer this. Why will the number n not apply to this next formula? But I mean, why can't there be an n? If you,
It's continuously.
right. I mean, think about what is n? N's how many times it happens every year, right? And if n is literally infinitely many times, there's no number that we can use realistically to represent that. Hence this other formula bailing us out. So before I make a list, I'm going to make a new page and I'm going to show you your new formula. And you absolutely need to write this one down. So here is your formula for continuous compounding. I know, it always makes me think of my drummer, my boy from the 80s, Neil Peart. You remember this?
Yes.
Good. So this is our PERT formula, and this one will only be used when the word continuously is in your problem. I feel like I say that the right way, but I still get questions about when to use it. So I'm going to say that again. If you're doing one of these compound interest problems and you see the word continuously, please immediately go to this formula. The one that has the 1 plus r over n, it can't work for this because n doesn't really exist in this scenario. So everybody got the PERT formula written down? The cast of characters is still exactly what you think they are. A is still the final amount, just like it always will be. P is still the starting amount. Like that's not any different, right? E is what does E represent? Right, it's not a variable, and that's I wasn't messing with you earlier when I said that. E is a number, so we don't think about like what am I going to put in place of E? E's not waiting for any input from you. E is a number represented by a letter, I know. And then always, what will R be? Your interest rate. Always make sure you convert that still to a decimal. That will never change. And then what is T? Your time, your number of years. Okay. So the cast of characters hasn't really changed. It's just that N got kind of voted off the island because he can't make any sense anymore because he's like, there's too many for me to be here. Right. So this is our PERT formula, and this is what we will use for any problem like this one that has the word continuously. So let's get to it. What is P? 7115, right? And what is, I appreciate the sentiment though. And what's R in this case, please? It is not 5.35. It is 0.0535, right? Let's just get in that habit of always saying it as a decimal 2 places to the left. And the only other thing we have to worry about here is T. Remember, there is no N. What is T? Good. So now that we have our super awesome PERT formula, then we would, to show our work, like when you take a quiz for me on this, I don't expect to see much work. I just expect to see, as is often the case, just show me what you put in your calculator. So it would look like this. I would do 7115. What goes right after that in the PERT formula? E. Yeah, I don't want to talk about the calculator just yet. I just want to get it down on paper first and then calculator. What did I say? I'm really tired. Did I mumble it?
Oh,
Thank you. I thought I did.
maybe I'm hearing.
And then I still have a multiplication problem, but I think you can already see the writing on the wall here. Normally our exponent is n times t. But in this PERT formula, it's not nt, it's rt. So we have to, now grabbing our calculator, we have to take r times t. So we're going to do, and it's okay for this part, grab your calculator and let's just do the arithmetic. 0.0535 times 40. And copy that decimal exactly up into your exponent, and that's 2.14. Got it? Now let's talk about on our different calculators, where is E? If you're using one of my TI-30X2Ss, I think you have to hit second and then the LN button, if memory serves me true. And do you see that up above the LN button, there's the little E to the power of? So what you guys are going to type in, and if you have your own calculator, I'll come work with you if you need some assistance. But on my rentals, or if you bought your own TI-30, then you would type it in like this, 7115. And then when you hit second LN, your calculator should say this. Does that match?
Mine says one.
It says LN because you forgot to hit second. No, just trust me on this one.
Okay.
Is this what yours looks like?
There we go.
That Trinity was R times T, because remember in the PERT formula that our exponent is R times T. So I just typed in whatever, well, R 0.0535 times 40. Got it? Okay. And then inside the parentheses, listen, the calculator some calculators don't do it this way, but it's just telling you like, what do you want me to raise E to the power of? Because it knows you want to multiply it to some exponent. So all you got to do is just stick in your 2.14 and then just, oh my God, and then just close it off. It's okay. And that's that. So let's do that together and then let's hit enter. Yeah, what's up? You can. So like what Diedrich is saying is, I'm not really saving any time, quite frankly, if I do it my way. So Diedrich's way is totally not wrong. He says, can I just put the 0.0535 times 40 and then close it off like that? And the answer is, you betcha. Like it's all going to come out in the wash. Yeah. So 7115 times E to the power of whatever, however you did it. We should, I hope, all get the answer of $60,473.50, because that 9's going to get bumped up to a 10 from the 8. So yeah, there's something going on with that other one. I'm almost done. I got one more example, and then God, this took way longer. But it's been a productive day, so it's all time well spent. Let's do one more.
Oh.
So again, I've highlighted for you in green. The moment you see that word continuously, you got to bust out the other formula, the PERT, right? The other formula is reserved for annually, daily, monthly, quarterly, semi-annually. I don't know. But continuously gets his own thing. A equals PERT. So here's the formula. And let's make our cast of characters. I always like to lay out the cast before I begin. So what's P? Yeah, 6,500. What's R? It is not 0.321. That would be 32.1%. I never thought in my career that this would be a hang-up point, but every year it is. Yeah, it's 0.0321. People really seem to struggle with that whole move the decimal 2 places. Like the rules change somehow. It's always 2 places. And then what's T?
Yeah.
So this time I'll show my work in a way like Diedrich said, and maybe you might like this more because it's technically one less math problem that you have to type in. So here's what it looks like. I'm going straight into my, well, not yet, but I'll go straight into my calculator with this. 6,500 times E. And then I hit this, it looks like this, and it waits and says, what do you want me to do? E to the what? And what Diedrich again was saying is, why not just type in 0.0321 times 58 and just let it do it all for you at once. And that is just fine like that. ¿Quién necesitas? Yo? Oh, un momento. No, no, gracias.
Era 41,000.
¿Qué?
41,000.
No sé.
¿Nueve?
41,829. Sí, perfecto. So everybody got $41,829.51. I have an assignment for you, and I'd like you to get a jump start on it. I realize it feels sure like it ought to be the end of the week, and we're almost there. But let me give this to you, and let's at least make a goal and say we're going to get maybe at least 3 problems done. And by the way, I staggered them so they go N formula, PERT formula, N formula, PERT. So you're going to see every other problem is continuous compounding.
Is it something